did you know that one mistake could cost millions of lives? In this story, the USA decided the fate of the war in just a few days. If you're interested in the truth about World War II, subscribe and hit the like button. There are many shocking facts ahead. Imagine this. It's mid-February 1943, and the scorching winds of the Tunisian desert whip across a barren expanse near Sidi Bou Zid. Suddenly, a tank rumbles into view, an American M4A1 Sherman. But something's not right. That iconic white star, barely visible beneath a hastily painted black cross. The tank grinds to a halt, its engine still purring as if defying the very sands beneath its treads. Officers of Heavy Panzer Battalion 501 close in, notebooks in hand, eyes gleaming with a mix of curiosity and disbelief. Before them stands a captured enemy war machine, intact, functional, and bearing secrets that would shake the foundations of German armor doctrine. This was not just any trophy of war. This was a technological wake-up call. War Daddy 2, the name emblazoned on its hull, wasn't just another Sherman, it was a harbinger of industrial might. Serial number USA 3067641, crafted by Lima Locomotive Works, assigned to Company G, 1st Armored Regiment, 1st Armored Division, and now a reluctant guest in Axis hands. Now picture this. German reconnaissance troops, seasoned veterans of desert warfare, climb aboard this foreign steel beast and set off on a grueling 350-kilometer journey across unforgiving North African terrain to the port of Sfax. 4.5 days. That's how long the journey took. And yet, this tank, this enemy machine, did something German vehicles seldom managed. It kept going. No overheated engine, no grinding to a halt, no failed transmission, no final drive malfunctions, just relentless motion. Can you feel the unease creeping in? To those German soldiers accustomed to coaxing their temperamental machines through even the shortest marches, the experience was both mesmerizing and deeply unsettling. Here was a tank that didn't complain, didn't falter, didn't need a mechanic's constant touch. It just worked. And so, at the port, War Daddy 2 was loaded with care onto a cargo ship bound for Germany. Orders from the Army Weapons Office were crystal clear. Deliver it to Kummersdorf, intact and fully operational. Up to this point, German intelligence had been piecing together reports fragments, whispers about American tank production. But this was no longer theoretical. The Sherman was a steel and oil embodiment of something far more daunting, an industrial juggernaut powered by principles the German war machine had never prioritized: mass production and mechanical reliability. As the vessel crossed the Mediterranean, bound for the heart of the Reich, engineers back in Germany prepared themselves. They were about to confront truths they had long avoided, truths not measured in gun calibers or armor slope, but in crankshafts, gears, and gaskets that simply didn't fail. Spring 1943, Kummersdorf Proving Ground, Brandenburg, just 25 kilometers south of Berlin. The rail car groaned to a halt, and down rolled War Daddy 2, now marked as Fahrzeugfahrzeug 259, bearing the German military license plate WH058941. But make no mistake, this was no ordinary test subject. It was a mirror held up to the face of German engineering. By now, its surface had been transformed. Every plate of armor bore detailed measurements. Every angle, thickness, and bolt had been meticulously stenciled in chalk-white script. This wasn't vandalism, it was reverence. Engineers at Kummersdorf were preparing for what would become one of the most detailed mechanical evaluations of the war. Inside the sprawling grounds of Kummersdorf, where captured Allied equipment was scrutinized alongside the Reich's own creations, the Sherman was about to face a gauntlet of German precision. Engineers, machinists, transmission experts, armor analysts, all converged, forming an elite task force of curiosity and caution. Their mission? Understand how this American tank defied the expectations of the German war machine. From track tension to engine endurance, every system would be stripped bare, recorded, and analyzed with ruthless efficiency. And as they began their initial inspections, perhaps more than a few wondered, how had the Americans, dismissed for so long as industrial amateurs, produced a tank that refused to break down, even under conditions that humbled the best of German steel? The sun beat down on the dusty proving ground at Hillesleben as engines roared to life, and the assembled crowd of Wehrmacht officers, engineers, and industrial leaders turned their attention to the row of armored giants lined up for the trial. Among them, the American Interloper stood silently, its olive drab hull now bearing German stenciling, but its heart still unmistakably foreign. War Daddy II, the Sherman tank that had crossed deserts and mines alike, was now part of a demonstration meant not just to compare, but to confront. Reichsminister Albert Speer, standing beside his staff, watched intently. For him, this was more than spectacle. This was data, insight, leverage. Every gear shift, every slip or surge of the tanks on the incline would speak volumes not just about machines, but about entire nations' capacities to wage modern war. As the trials commenced, the tanks advanced one by one up steep earthen ramps, their engines straining, treads clawing at the soil. The Panther Aus von D moved with the grace of a predator, but betrayed a sense of overburdened power, sleek, lethal, but temperamental. The Ferdinand, enormous and brutal, thundered up the grade, but its weight made every movement feel like a gamble against gravity. And then came the Sherman. With almost casual confidence, it climbed. No drama, no mechanical shriek, no flailing tracks, just steady torque and dependable traction. German observers took note, not of superior armor or firepower, those were absent, but of something more insidious, a kind of brutal, unrelenting functionality, a machine that simply did what was asked of it, again and again and again. Behind the scenes, notebooks filled with figures, climb angles, fuel rates timed to summit, but between the lines, what was written could not be quantified so easily. A growing sense of unease. This tank, mass-produced by a nation thousands of kilometers away, was not supposed to hold its own beside Germany's most advanced armored beasts. And yet, it had. What did it mean when a lesser machine refused to break? When it outlasted its more sophisticated counterparts, not by brilliance, but by sheer, stubborn consistency? For Speer, the implications were chilling. Germany's future in tank warfare had long been tied to technical superiority, to mastery of metallurgy and precision mechanics. But now, he was forced to consider a different battlefield entirely, one fought in factories, on production lines, with simple tools wielded by thousands of workers building not perfect machines, but good enough ones in overwhelming numbers. As the demonstration concluded and officers dispersed, the image of War Daddy II climbing the hill without falter lingered. Not because it was the best tank on the field, but because it was the tank that wouldn't stop working. And in a war that showed no sign of ending, that was perhaps the most dangerous feature of all. The answers Albert Speer had hoped not to hear were now laid bare in steel and smoke. As War Daddy II climbed the test slope With a fluidity that seemed almost casual, its 5-speed manual transmission shifted seamlessly from gear to gear, synchronized from second through fifth. No grinding, no hesitation. The engine kept delivering consistent power undaunted by the incline. The driver, with minimal effort, handled the Sherman like a well-trained horse rather than a stubborn beast. His movements calm, confident, and almost dispassionate. This was not just performance, it was predictability. Then came the Panther, its sleek hull and formidable 700 horsepower Maybach HL230 engine promising dominance. But though it matched the Sherman's climb, it did so only barely and with visible struggle. Shifting was harder, torque was less forgiving, and power surges required more skill to manage. And then, catastrophe. The Ferdinand massive, proud, technologically advanced lurched and faltered. Halfway up the slope, its electric transmission failed. Before a crowd of senior officers and industrial elites, the behemoth rolled to a halt. Crews scrambled, red-faced, to restart it. They couldn't. Speer said nothing, but the silence was deafening. Years later, in his memoirs, he would recall this moment not as a singular embarrassment, but as a turning point. In October 1944, touring occupied Italy, Speer would again reflect on the Sherman. Reports he received described American tanks crossing mountains considered inaccessible by German armor. The 26th Panzer Division specifically noted the Sherman's mobility as superior. Why? Because it possessed a powerful engine in proportion to its weight. Its cross-country performance on flat terrain was not just acceptable, it was beyond what German designers had believed possible. And Speer, as the man responsible for arming the Reich, took those observations seriously. On June 27, 1943, an article appeared in Das Reich newspaper. The tone was restrained, carefully curated for public consumption. It called the Sherman a product of North American steel laboratories, an achievement of industrial strength, not battlefield dominance. Yet even in its measured language, truth seeped through. The article praised the Sherman's serial production and its fulfillment of what it called the almost arrogant expectations of the American automobile industry. It acknowledged the gyro-stabilized gun as a world-first innovation. It was, for a publication serving the propaganda machine, a startling admission. The Americans were ahead in ways that mattered. Back at Kummersdorf, testing pressed on through summer and deep into autumn. Every component, every system was subjected to extended field trials. Engineers pushed War Daddy 2 to its absolute limit. They charted operational ranges exceeding 2,000 kilometers before any major maintenance was required, 4 times the typical field endurance of early Panthers. They recorded drivetrain power losses far lower than any German system could boast. Gear changes, thanks to synchronized transmission, remained smooth and effortless throughout. There was no need for double clutching or finely tuned rev matching habits that German drivers had to master over weeks of instruction. In contrast, a Sherman driver could be trained in days. Then came another revelation. Final drives, those critical, vulnerable components, had long plagued German tanks. The Panther had inherited its final drive design from the Tiger, straight-cut gears inside cramped housings that cracked under pressure. Time and again, Panthers had been abandoned in North Africa and on the Eastern Front after only short marches, sometimes less than 100 kilometers, because of final drive failures. But the Sherman, its final drives were built on the same herringbone gear principles as its transmission. They didn't break. They didn't falter, even under brutal combat conditions. Restoration experts, working decades later, would find Sherman final drives that still functioned perfectly after years in storage, a testament to generous design margins that exceeded wartime requirements by orders of magnitude. By the close of 1943, Kummersdorf had gathered more than just test results. They had assembled a complete, damning portrait of American design philosophy. Practical, scalable, unbreakable. Internal reports flowed through Wehrmacht technical divisions like quiet warnings. The enemy had built a tank not to impress but to endure, and that was far more dangerous. The internal documents circulated through high command corridors were never meant for public eyes. Their tone was clinical, their content damning. Addressed to senior Wehrmacht officers and officials within the Ministry of Armaments, they revealed an uncomfortable truth. The Sherman represented a level of automotive engineering maturity that Germany, despite its vaunted precision and scientific prestige, simply did not possess. And the reason why had nothing to do with intellect. It was a matter of industrial culture. Where German manufacturing insisted on tight tolerances and perfect fits, American factories embraced broader margins, designing machines that tolerated imperfections. It should have produced inferior results, but in war, where dust, mud, and chaos ruled, it did exactly the opposite. The Sherman endured. German tanks broke. Think about it. What if reliability wasn't found in obsessive perfection, but in strategic imperfection? American tanks weren't flawless. They were fixable. And that changed everything. Interchangeable parts, designed for field repair with basic tools, meant that a broken Sherman could be patched up and rolling again in hours. No need for factory-grade machinery, no need for elite technicians. German tanks, by contrast, demanded expert maintenance with specialized tools, and even then, breakdowns were frequent and costly. The entire American design philosophy screamed one priority: keep the tank moving. The engineers at Kummersdorf began to see the deeper implications. These weren't just tanks. They were the result of an industrial mindset forged in civilian automotive abundance. Before the war, millions of Americans owned cars. Mechanics were everywhere. Skills were widespread. In Germany, cars were rare. Civilian automotive infrastructure was immature. The famous Volkswagen project had promised mobility to the average German worker since 1934. Yet by 1939, fewer than 1,000 had been delivered. While Americans learned to drive and repair cars in adolescence, Germans still viewed automobiles as status symbols reserved for party officials and industrialists, and so the divergence extended into the battlefield. American tank crews didn't need years of training. Many already had mechanical knowledge from their civilian lives. The Sherman was designed with them in mind, familiar layouts, easy access, parts that matched across variants. German tanks, by contrast, were complex instruments requiring constant nursing by professionals with years of specialized education. By late 1943 and into early 1944, this disparity could no longer be hidden. Field reports from the Eastern Front and Italian campaign painted a grim picture of German reliability. Panthers, for all their impressive specifications, were brittle. Drivers were instructed not to shift too often, especially not into third gear, which shattered so frequently that manuals warned against using it unless absolutely unavoidable. Turning while reversing? Forbidden. It would destroy the transmission. Pivot turns? Only possible if ground resistance was exactly balanced on both sides. A stick or stone caught in the drive sprocket could sideline a Panther for hours. The tank was powerful, but it was fragile like a racehorse galloping on splintering legs. And these weren't rushed wartime constructions. They were built in dedicated facilities by skilled workers using Germany's finest materials. Still, they failed. The Sherman, in stark contrast, had been born in the minds of automotive giants General Motors, Chrysler, Ford. Engineers who had mass-produced vehicles for the American public now turned their skills to tanks. They pulled components from commercial production lines, standardized them across the board, and built them to function in the field, not just on paper. Transmissions were sourced from Caterpillar, Buick, Ford, each one identical in form and function. A transmission from one factory could be dropped into a Sherman from another with zero adjustment. It was plug and play before the term existed. Germany had no equivalent. Parts varied subtly between manufacturers. True interchangeability was a theoretical goal, not a practical reality. More Shermans continued to arrive at Kummersdorf throughout 1943 and 1944. They came from the deserts of North Africa, the mountains of Italy, and the steppes of the Eastern Front. Some bore American markings, others had passed through British hands. A few had fought under Soviet command. Each one was disassembled, studied, tested, and added to an ever-growing archive of American capability. One variant in particular caught German attention, the Firefly. British forces had retrofitted the Sherman with their fearsome 17-pounder anti-tank gun, addressing the M4's known deficiency in firepower. German engineers approached it with curiosity, expecting to find crude improvisation. But what they discovered was something far more impressive. The Sherman's original design had incorporated enough space and structural tolerance to accept the larger gun with minimal modification. The oversized turret ring accommodated the new weapon, and balance remained within acceptable limits. It wasn't a perfect solution, but it was effective, and it proved a point the Germans had overlooked. The Americans had built not just a tank, but a platform, one that could evolve. That idea disturbed more than one engineer in those quiet offices south of Berlin. The Sherman, dismissed early in the war as a primitive design, had revealed itself to be the product of a different kind of brilliance. Not one of revolutionary breakthroughs or engineering bravado, but of foresight, pragmatism, and relentless industrial competence. The Panther had been Germany's urgent answer to the Soviet T-34A rush of steel and ambition forced into production before its time. It looked menacing, it struck hard, but its design left little room for growth. There was no practical way to significantly upgrade its main armament without reimagining the entire turret or even the hull itself. In contrast, the Sherman had already shown flexibility in this regard with variants like the Firefly. But the real battlefield verdict wouldn't come from guns or armor profiles. It would come from motion, from endurance, from the question, when the order comes to advance, which tank actually moves? To find the answer, German engineers expanded the Kummersdorf program. It was no longer just about measurements and diagrams. It was about simulation. Shermans were driven across hundreds of kilometers of rough terrain in carefully controlled reliability trials. Every jolt, every creak, every mechanical response was documented. Every maintenance stop, every lubrication cycle, every failure no detail was too small. And then came the comparisons. engineers laid these results beside hard field data gathered from Panther and Tiger units slogging through the Eastern Front in Italy. The verdict was blunt and brutal. Panther readiness rates hovered below 40% for most of 1943. In some months, entire battalions reported operational availability as low as 20 or 25%. Imagine that, fewer than 1 in 5 tanks ready for battle. And those weren't training models. They were supposed to be Germany's armored spearhead. Meanwhile, Sherman units in every theater, Italy, North Africa, the Pacific reported operational availability well above these figures, despite longer supply lines and tougher conditions. And then came the numbers from Kursk. Operation Citadel, July 1943. Panthers entered the battlefield with 16% operational readiness, not because the enemy had struck first, but because the tanks failed before firing a shot. By December 1943, improvements had pushed that number to 37%. February 1944, still 37%. April climbed to 50%. May finally reached 78%. But even that success paled in comparison to Sherman readiness, which had met or exceeded those levels from the very beginning. While German engineers framed these figures as progress, they also quietly acknowledged the truth. Panther reliability had started catastrophically low, and even at its best, it still lagged behind. Sherman engine lifespan under proper maintenance surpassed 3,000 kilometers. Panther engines? Barely 1,000. Even the improved versions introduced in 1944 were celebrated for reaching 700 to 1,000 kilometers. This wasn't victory. It was damage control. The Sherman diesel variant simply lasted longer. Its transmission system required little attention between overhauls. Synchronized gears meant fewer driver errors, smoother transitions, and less wear. Panther transmissions, on the other hand, were notoriously delicate. Third gear failures were so frequent that crews adopted unofficial workarounds, jumping from second to fourth just to spare the gearbox. That wasn't doctrine. It was desperation. And then there were the final drives. Sherman final drives, built with robust herringbone gear systems, absorbed punishment that would cripple a Panther. Time and again, Panthers lost mobility within a 100 to 200 kilometers of frontline service due to final drive failures. Shermans, by contrast, rolled on. Some German crews reported operating captured Shermans for weeks in combat without touching the drivetrain. Imagine the psychological effect. German crews watching their own elite tanks fail, while enemy machines captured in battle simply worked. And yes, German panzer units used them as 1943 bled into 1944, and as the German tank inventory withered from attrition and mechanical breakdown. Field units began seizing intact Shermans not out of curiosity, but out of necessity. Unlike captured Soviet T-34s, which required modification before they could be trusted, Shermans needed no alterations. They worked out of the box. German mechanics respected them. German drivers trusted them. Reports from units using captured Shermans confirmed everything Kummersdorf had tested. The tanks were consistent, predictable. Mechanical failure was rare enough to be an exception, not an expectation, and for German crews who had learned to plan every operation around the limits of their vehicles, this was transformative. Sherman operators could focus on terrain, on enemy positions, on tactics. Panther and Tiger crews? They focused on the machine on coaxing it to move, on praying it wouldn't collapse before the objective. Every kilometer was a wager. In war, some weapons inspire fear, others inspire confidence. The Sherman, humble in design, did something few tanks could claim. It let its crew fight the enemy instead of the machine. In January 1945, amid the frozen chaos of Operation Nordwind, a remarkable scene unfolded near Herlesheim. 12 American M4A3 Shermans, abandoned in haste by the 43rd Tank Battalion under the weight of the German assault, stood intact on the battlefield engines, silent, guns cold, but otherwise untouched. These weren't burned-out husks or gutted shells. They were fully operational machines, left behind in a moment of tactical retreat. The 10th SS Panzer Division wasted no time. The Shermans were seized, repainted, and reassembled as the newly formed 13th Company of the 10th SS Panzer Regiment. And just like that, American tanks re-entered the war, this time under German command. Their role wasn't symbolic. These Shermans served in combat, deployed as reconnaissance vehicles and mobile reserves. Tasks that demanded more than armor or firepower, they required trust. Trust that the tank would start when ordered, drive when commanded, and not grind to a halt when most needed. German commanders, many of them veterans of the Eastern Front, knew exactly what that meant. They had already read the Kummersdorf reports. Now they lived them. In those final desperate months, the most precious battlefield commodity was not firepower. It was dependability. A Sherman that reached the front was worth more than a Panther that never left the depot. Back at Kummersdorf, January 1944 brought a new wave of testing. Wehrmacht forces were now in retreat on multiple fronts, and captured equipment flowed into Germany in a grim tide. Engineers examined every Sherman variant that passed through their gates. The M4A1 with its Continental R975 radial engine was studied and cataloged. The M4A2 with its dual General Motors 646 diesel engines drew particular interest for its superior fuel economy. The M4A3, powered by Ford's GAA V8 gasoline engine, the favorite among American crews, was tested extensively. What shocked the German engineers wasn't that one variant excelled. It was that they all did. Different engines, different factories, yet the same core traits emerged every time: smooth transmission performance, rugged drive train construction, ease of maintenance, and most of all, reliability. This consistency stood in a sharp contrast to German experience, where even tanks of the same model could vary wildly in quality, depending on the manufacturer. The Americans had mastered something elusive: standardization at scale. The diesel-powered M4A2 stood out. German engineers dissected the engine with methodical precision. Reports confirmed what Soviet experience had already shown. Lend-Lease shipments had delivered over 4,000 M4Ahos to the Red Army, and dozens had fallen into German hands during the long retreat from the east. The twin GM 604I6 diesel was not only fuel efficient, but it matched the performance of gasoline-powered variants, a critical asset for a Germany running increasingly short on fuel. German designers had dabbled in diesel tanks, but abandoned the effort, defeated by the complexities of fuel injection and inconsistent machining tolerances. The Americans, by contrast, built diesel Shermans in parallel with gasoline variants without skipping a beat. That kind of industrial dexterity left German engineers in quiet awe. March 1944 brought a series of communications from General Heinz Guderian, Inspector General of Panzer Troops. In official memoranda, he proudly declared that Panther reliability had finally reached what he called acceptable levels. Engine lifespan now stretched to 700 or even 1,000 kilometers. Final drive failures had declined. It was a victory, at least on paper, but the comparison spoke for itself. These achievements merely brought the Panther up to the standard the Sherman had already set 2 years earlier. The bar hadn't been raised. Germany had just struggled to reach it. And while German engineers celebrated this hard-earned stability, the war outside the lab grew darker. Allied bombers began to zero in not just on cities, but on the lifeblood of German armor, its factories. Strategic bombing focused on the soft underbelly of the Panther and Tiger supply chains, targeting where tanks were truly born, not on the assembly line, but in the engine bays and gearbox foundries. On the night of April 27-28, 1944, the Royal Air Force struck a devastating blow. 322 aircraft turned Friedrichshafen into a furnace. The Maybach plant, responsible for Panther and Tiger engines, was shattered. Adjacent to it, the ZF gearbox factory was also destroyed. For 6 months, tank powertrain production came to a grinding halt. And when it finally resumed in November 1944, the war had changed. So had the factories. Skilled labor was gone, drafted, wounded, dead. In their place, forced labor, prisoners, slaves, and some of them fought back with the only weapons they had. Small acts of sabotage, cigarette filters shoved into oil channels, gaskets reversed, bearings misaligned. The Panther may have looked the same on the outside, but inside it had begun to rot. The Sherman, meanwhile, kept rolling built in factories that still had electricity, clean floors, and well-fed workers. The contrast couldn't be starker. In the end, Germany hadn't just lost a race of machines, it had lost a race of philosophies. One built tanks for parades and technical journals. The other built tanks that started every morning, no matter the weather, and drove straight into history. As German factories reeled from bombing raids and faced growing shortages in material and manpower, the tanks they produced began to betray the cost of war, not just in steel, but in precision. Components arrived misaligned, clearances were off, gears failed to mesh. The same tanks that once rolled from assembly lines with pride now limped out with hidden flaws that would soon strand them in mud, snow, or worse, under fire. These problems never plagued Sherman production. Thousands of kilometers away across the Atlantic, American factories operated in peace, untouched by enemy bombers, staffed by workers earning fair wages in clean facilities, motivated by a cause, and supported by a robust economy. They built tanks with confidence tanks that worked. At the heart of it all lay a truth few in the Reich dared speak aloud. The divide between American and German tank production wasn't one of knowledge. It was one of philosophy. German engineers were brilliant, there was no doubt. They understood automotive theory with the same depth and rigor as their American counterparts. But theory is not practice, and in Germany, it remained trapped on paper, buried under priorities that emphasize performance curves over practical outcomes. German tanks were built to impress. The Panther's powerful 75 mm K-42 cannon and thick frontal armor looked magnificent on specification sheets. But beneath that armor, the overworked powertrain groaned under the 45-ton weight, pushed to its limits every time the engine started. The Tiger, a legend in its own right, demanded constant attention, a prima donna of the battlefield. It required trained specialists to coax it forward, armed with tools, technical manuals, and patience. These machines weren't just vehicles, they were obligations. In theory, these trade-offs could be justified if Germany had the resources to build enough of them and the spare parts to keep them running. But reality had other plans. Allied bombers hammered factory after factory. Raw materials grew scarce. Skilled labor vanished into military conscription. And slowly, the dream of German armored dominance broke down not in battle, but on the factory floor. Meanwhile, American engineers, veterans of Detroit, trained in the rhythms of automotive mass production, took another path. They designed the Sherman not as a miracle machine, but as a reliable, repairable tool of war, a tank that could be built by the tens of thousands, a tank that could be fixed in the field by men who had repaired cars before they carried rifles. The Sherman's powertrain came straight from America's highways, refined, proven battle-ready, without needing to be battle-born. Even its electrical system reflected this thinking. It featured a backup generator for turret traverse, allowing the gun to rotate even if the main engine died. To German designers, this seemed a frivolous luxury, unworthy of consideration. But for tank crews stuck on a slope, engine stalled, enemy sighted, the ability to swing a turret and fire meant survival. German crews, haunted by turrets frozen in place when their engines failed, could only dream of such practicality. Spring 1944 brought a grim new chapter. Wehrmacht reports from every front echoed a common theme: breakdowns. More and more Panthers failed not under fire, but under motion. Their final drives, still fragile, couldn't survive sustained marches. Any journey longer than 100 kilometers demanded rail transport, not for convenience, but for survival. Orders were issued: limit Panther movement, conserve the machines, save them for actual combat if they made it that far. Even the Berger Panther, designed to tow broken Panthers, shared their fatal flaw. It could recover little when it too broke down. Field commanders now fought two enemies, Allied armor, and their own machines. Some units reported that up to 70% of tank losses came not from battle, but from internal failure. And still the Shermans came. They rolled off American assembly lines with a rhythm no German factory could match. By war's end, 49 out of 124 Sherman tanks had been produced, more than the total of all German tank types combined. Britain received thousands through Lend-Lease. The Soviets, over 4,000 diesel-powered M4A2s. Even Chinese forces used Shermans in Burma, overwhelming Japanese armor with ease. Wherever they appeared, the verdict was the same. Shermans ran. Kummersdorf had shown it. Now the world confirmed it. Even the Sherman's most complex engine, the Chrysler A57 multibank, a fearsome tangle of 5 individual engine blocks, proved easier for German mechanics to maintain than their own Maybach engines. It sounded unbelievable, but the reports were clear. The A57 was intricate, yes, but accessible. It didn't demand specialist knowledge or endless valve adjustments. The Ford GAA V8, widely regarded as the best Sherman engine, further impressed German crews with its raw power and rare need for fine-tuning. To those accustomed to Maybach engines, machines that needed constant adjustments to timing, valve clearance, and carburetors, it felt like breathing clean air after a storm. And then there was the twin GM diesel, rejected by the U.S. Army for being less reliable than gasoline engines. The diesel variant exceeded all expectations in the hands of German testers. It surpassed any diesel engine Germany had managed to build for tanks. Another painful reminder that industrial strength wasn't about brilliance alone, but about scale, consistency, and experience. Perhaps most telling of all was the Sherman's capacity to grow. Its basic drivetrain, originally rated for a 30-ton vehicle, took on heavier variants with ease. The M4A3 Yahoo Jumbo, weighing over 42 tons and clad in reinforced armor, needed no major transmission redesign. The system simply worked harder and kept working. To German engineers, that level of foresight was humbling. In every bearing, every gear, every redundant system, the Sherman held one clear message: this tank was made to last. The same core components that had reliably powered the standard Sherman now absorbed 650 horsepower from experimental engines without redesign, without failure, without so much as a whisper of strain. To German engineers trained in austerity and precision, this seemed wasteful. Overbuilding was excess. Unused capacity meant wasted materials, luxuries Germany could not afford. But to American designers, forged in the fires of mass production and long-haul thinking, it meant something else entirely. It meant room to grow. It meant a tank that wouldn't break when pushed beyond its limits. It meant reliability that wasn't just acceptable, it was intentional. By summer 1944, that difference in philosophy echoed across the beaches of Normandy and deep into the French countryside. German tank commanders understood all too well that their disadvantage was no longer technical. It was total: artillery, air power, supply chains. The Allied war machine was a storm, and it moved with a momentum that German tactics alone could not reverse. And at the center of that storm rolled the Sherman. Its firepower may not have matched the Tigers, its armor might not have equaled the Panthers, but it moved, it fired, it came back, and then it went again. American armored battalions launched offensives, held positions, pursued retreating enemies, and prepared for the next assault, all without lengthy maintenance delays. Shermans didn't pause. They persisted. German panzer divisions, by contrast, operated like delicate instruments. Every maneuver had to be weighed. Every kilometer was a calculation. Would the gearbox hold? Would the final drive survive the march? Tank commanders became accountants of metal fatigue, rationing their combat power not by enemy strength, but by mechanical limitations. The difference wasn't just in machines, it was in momentum. One army advanced, the other cautiously followed its own shadow, and yet, even as the war tilted irrevocably westward, German commanders clung to the one truth they had learned at Kummersdorf: in the field and in the fire, Shermans worked. Nowhere was that belief more apparent than in the formation of the 150th Panzer Brigade, created for infiltration operations during the Battle of the Bulge in December 1944. Its mission was deception German soldiers dressed in American uniforms, operating captured American vehicles to penetrate Allied lines. What did they ask for? Not Tigers, not Panthers. They asked for Shermans, because they knew they would run. In the end, only 2 were delivered. One was deemed operational. Even that one never reached the front. Traffic congestion and logistical collapse ended the operation before it began. But the lesson was clear. In a mission that demanded absolute confidence in machinery, only American tanks offered even the chance of success. German armor, even at its best, couldn't promise that level of sustained performance. Then came the final reckoning. On January 23, 1945, the Panzer Commission convened. The war was turning to ashes, but still, the engineers gathered to confront the numbers. What they recorded was devastating. Across all German tank types, final drive failures had become endemic. 500 defective final drives in the Panzer IV, 370 in the Panther, 100 in the Tiger, 200 more in the Hetzer, derived from the Czech 38-ton chassis. Machines meant to strike fear now collapsed under their own complexity. General Lieutenant Wolfgang Tomele, Chief of Staff under Guderian, gave voice to what frontline crews already knew. Tanks could no longer be used in an orderly fashion. Troops had lost faith. In some cases, they simply walked away, abandoning intact vehicles for fear of being stranded in enemy territory. The enemy no longer had to destroy German tanks. The machines were doing it themselves. All those years, all those grand designs, all the promises of invincibility undone by gears, gaskets, and bad bearings. German tanks had been built to intimidate, to stand as steel giants. But in the end, they had failed in the one mission that mattered most: to survive the road and deliver fire when it counted. In early 1945, as the Soviet steamroller approached Berlin, even the fortress of Kummersdorf began to fall. Engineers worked through the night, frantically boxing up years of testing data. Crates of technical drawings, performance logs, and evaluation reports were shipped westward in hopes that somehow the knowledge might outlast the war. Perhaps they understood even then that the true lessons of the Sherman were not just about engineering or production. They were about endurance, about building something that didn't need to be perfect, just something that never stopped working. As the Red Army closed in on Berlin and the Third Reich teetered on the edge of collapse, every functioning vehicle, regardless of origin, was pressed into the fight. Among them were captured tanks, including at least 2 Shermans, hastily reassigned to frontline service. These machines, originally forged in American factories and tested under German scrutiny, now rolled side by side with the last Panthers and Tigers, defending the shattered heart of Germany in the final days. These Shermans, just like those tested at Kummersdorf, did what they had always done. They functioned. They fought. They kept moving until destroyed by direct hits or simply ran dry, abandoned when fuel became as scarce as hope. Their German counterparts, even in these final moments, continued to betray their crews. Panthers stalled. Tigers overheated. Mechanical failures spread like infection through exhausted Panzer units. Even veteran crews, long hardened to breakdowns, were stunned by the rate of failure. The story of War Daddy II and the dozens of other Shermans disassembled, cataloged, tested, and studied at Kummersdorf is not simply a tale of tank comparisons. It is a reflection of one of the greatest industrial divides of the Second World War. German engineers, steeped in theoretical mastery and driven by a pursuit of mechanical elegance, created machines that dazzled on paper and in propaganda reels, but crumbled under the sustained pressure of war. American engineers, with grease on their hands and experience under their belts, designed machines that lacked glamour but delivered again and again on every battlefield, under every condition. In armored warfare, as in all combat, the weapon that works now beats the one that might have worked someday if only it had made it to the fight. After the war, as Allied intelligence pored over captured documents and wreckage, the conclusions were blunt and undeniable. Systematic post-battle analysis of destroyed German tanks revealed mechanical failure to be just as common a cause of loss as enemy action. Final drives shattered under strain, transmissions seized from poor lubrication, engines cooked themselves into ruin from heat and oil starvation. German engineering had chased perfection without asking whether it could be sustained, repaired, or reproduced. The result: weapons that only the most elite technicians could maintain, dependent on spare parts that required bespoke logistics and a war machine that ultimately broke itself. Kummersdorf, once a symbol of analytical rigor, became a cautionary tale. And yet, its legacy endured not in the twilight of the Reich, but in the rebirth of a new army. When the Federal Republic of Germany began designing the Leopard 1 main battle tank in the 1950s, it did so with lessons burned into memory. West German engineers deliberately turned away from the mistakes of the past. They studied the Sherman. They studied American production models. They prioritized reliability, maintainability, and standardization, not abstract superiority. The result was profound. The Leopard 1 featured a robust, overbuilt powertrain. It was easy to maintain, requiring few specialized tools. It was modular, allowing field repairs and upgrades without full redesigns. It was a machine born not of ego, but of wisdom, and it would go on to become one of the most successful tanks of the Cold War, fielded by dozens of nations and serving well into the 21st century. War Daddy 2, with its painted name still faintly visible on its captured hull, represented far more than a battlefield trophy. It was a symbol, a steel witness to the truth that no amount of theoretical innovation can substitute for practical experience, industrial discipline, and a deep understanding of what war demands, not on paper, but in motion, in dust, in fire. What the engineers at Kummersdorf discovered under the hatches of those Shermans wasn't just a different kind of tank. It was a different kind of thinking. German tank designers pursued advanced specifications with a singular belief that superior technology could overcome numerical inferiority, resource shortages, and encirclement on every front. They gambled that precision and performance would triumph where scale could not. They were wrong. American designers, battle-hardened in both factory and field, took a different path. They understood that wars are won not by the machines that look best on paper, but by the ones that arrive at the fight, survive it, and roll forward again. They were right, and that understanding proved decisive. This gap, this reliability chasm between the Sherman and its German counterparts, did more than shape battlefield encounters. It reshaped the very understanding of industrial warfare itself. Germany entered World War II with weapons that often outclassed those of their enemies in terms of raw capability. German engineers were brilliant, their technical knowledge immense. But brilliance alone could not mass-produce tanks. Technical superiority could not replace supply lines. Precision machining could not substitute for logistical depth. Germany simply didn't have the industrial stamina to scale its advantage, and in modern warfare, that made all the difference. The United States entered the war with weapons that were, in many cases, less advanced, but they brought something far more important: a machine behind the machine, a mature industrial system honed through decades of automotive production, capable of building, refining, and sustaining weapons in vast, relentless volume. Shermans were not just built, they were iterated, improved, adapted in real time based on field reports. They reflected a system that learned as it fought. The Sherman tank, in its seemingly modest form, became the perfect expression of this industrial logic. While Germany struggled to keep Tigers and Panthers operational, America built Shermans faster than they could be destroyed and made them better with every new batch. The numbers told the story. The United States built nearly as many Shermans as Germany built all types of tanks combined, and that was just a fraction of total output. America also armed its allies, supported entire theaters of war, and maintained the highest standard of living among all combatants all at once. That was not luck. That was industrial power. And so the calculations became painfully simple. A Sherman with a 75mm gun that reached the battlefield was worth infinitely more than a Panther that never arrived or needed 3 days of maintenance for every hour in combat. An armored battalion with 80% operational readiness could seize objectives, pursue retreating enemies, support infantry, exploit breakthroughs. One with 40% readiness could do none of these things. Reliability was not a luxury. It was the foundation of military effectiveness. And time and again, German tanks failed that test. American tanks passed it. By mid-1943, the engineers at Kummersdorf knew this. Their data didn't lie. They had tested Shermans under every condition imaginable, recorded every result with scientific discipline. They had seen the final drives last, the transmissions endure, the engines survive, punishing marches that shattered German machines. They wrote detailed reports. They conducted comparative trials. They reached the only conclusion possible. America had solved a problem Germany had failed to define, and yet understanding a problem is not the same as solving it. German industry, stretched thin by war on 3 fronts, by collapsing supply chains, by Allied bombing and critical labor shortages, could not retool. They could not sacrifice performance for reliability, not when propaganda demanded ever larger guns and thicker armor, not when ideology placed spectacle above sustainability. Meanwhile, America simply applied what it already knew. Reliability wasn't invented for the Sherman, it was inherited from millions of cars and trucks that had driven across plains, cities, and mountains since the 1920s. That mindset, build it simple, build it strong, build it to last, was already part of the American industrial DNA. And then there was War Daddy 2, a single Sherman captured in Tunisia, dragged across continents, dismantled and dissected at Kummersdorf. It became the test case, the mechanical witness. Every kilometer it traveled without breakdown told a story in silence. Germany had designed tanks for power. America had designed tanks for war. Every hour of flawless operation stood as quiet condemnation of German priorities. Every gearbox that refused to fail, every synchronized shift that eased the burden on the driver, every rugged component that ignored heat, dust, and time. Each one whispered the same truth. This is what winning looks like. War Daddy 2 was not special. It was one of nearly 50,000, and that was the point, because what it represented was a truth too devastating to ignore, that the war had already been lost, not in the forests of France or the steppes of Russia, but in the factories of Detroit, in the tool shops of Toledo, in the conveyor lines of Cleveland. German commanders saw it. German engineers recorded it. But by then, it was too late. The Shermans didn't win the war because they were better. They won because they were enough and because they never stopped arriving.